Hello students, today we are doing lesson 9.1, factoring common monomials. So last lessons in chapter 8, we learned about adding, subtracting, multiplying, and dividing polynomials, and now we're going to be factoring them. So this is kind of like distributive property backwards. Okay, so let's just start with some back knowledge. So GCF is what we're going to be using today. And if you remember, that stands for greatest common factor. So let's talk about factors. So if I had the number 8 and the number 16, and I wanted to find their GCFs, I would first look at what their factors are. So their factors for 8 would be 2, 4, and 8, right? So factors are numbers that can divide, 8 can be divided by and come out with no remainders. Or numbers that when multiplied make 8. So, and one of these factors is 1, but we don't usually talk about the factor of 1 in algebra. Okay, so 16 would be 2, 4, and 8, and 16. Okay, so this one has 4 different ones. Okay, so the GCF is exactly what it says. It's the greatest of these factors that are in common. So these two have a lot in common. They have 2, 4, and 8. So the greatest one is 8. So the GCF for 8 and 16 is 8. Is 8. Okay, so that's what we're going to be doing with a bunch of our problems today. And we're going to add in variables because it's algebra, right? So let's go ahead and get started with the first one. Example 1 says factor 8x squared minus 16. Okay, so the first thing you have to do in factoring these, remember I told you it's going to be like backwards distributive property. So let me show you what I mean by that. Okay, we're going to look at the problem and we're going to look at the numbers first. So these numbers are 8 and 16. That's why I use them up here. So you ask yourself, what is the GCF of 8 and 16? Or what number can those both be divided by? The highest number they can both be divided by. And that would be 8. Okay, and then you're going to look at your variables. Well, on this one, because they started out with an easy one, only one of them has a variable and the other one does not. So I don't have any variables to deal with because they do not have a common variable. So we only do variables if they have a common variable. So now I'm going to put my parentheses, okay, kind of like in distributive property. And I'm going to use this and I'm going to say, what do I need to multiply by 8 to get 8x squared? Well, I would just need to multiply x squared, right? Because 8 times x squared is 8x squared. And then I put my minus sign and I say, what do I need to multiply by 8 to get 16? And the answer to that is 2. And that is my answer. Now you can always check your answer by going back and doing distributive property like this and saying 8 times x squared is 8x squared, 8 times 2 is 16, and do you see how it's the same thing as up here? Okay, let's move on to another example, and in this one, we will have a variable in it. So let's do example 2. Example 2 says factor 3x squared y minus 27xy plus 9xy cubed. Okay, so this one has 3 terms in it, but we're going to do it the same way. Take it step by step. First, you look at your numbers. We have 3, 27, and 9. So if you wanted to find your GCF, you could write them all down. I'm just putting them in order. And this 3 only has 3. That's the only number it can be divided by. 9 is 3 and 9. 27 is 3, 9, and 27. Okay, so what is the greatest common one they have? Well, they only have one common one, so this one was easy, and that's 3. So that's the number we're going to take out of the parentheses. So that one's going to be on the outside, 3. And now before we put that parentheses, like we did up here, we had a parentheses right away, is we need to look at our variables. So I have an x squared y, an xy, and an xy cubed. So they do have variables in common. They all have an x and they all have a y. So let's look at the x's first. I have x squared, x, and x. So I'm only going to be able to take out an x, not an x squared, because these two do not have x squared to take out. They only have one x. So on these, you're really going with the lowest exponent. Okay, and then for y, I have a y here, and a y here, and then a y cubed here. Okay, so I'm only able to take out one y because I can't take out y cubed from here, right? Because there's only one there. So on your variables, you're taking out the lowest exponent. Okay, and that's it. Now I'm going to do my distributive property, and I'm going to look at each one individually. So what do I need to multiply 3xy by to get 3x squared y? And that would be just x. I only have to multiply it by x. See, if I multiply those two, I get 3x squared y, just like up here. Okay, and then I'm going to put my minus sign. And now I need to ask myself, what do I need to multiply 3xy by to get 27xy? Well, the xy is already here, so I don't even need to put an xy. I only need a 9 because 3 times 9 is the 27, and then I have the xy already on the outside. Okay, moving on to the last term. I have 9xy cubed, and I need to say, what am I multiplying this by to get 9xy cubed? So the answer is 3y squared. Okay, so let's look at how I got that answer there. When I multiply 3 times 3, I'm going to get the 9. Okay, so that part was easy. And then up here, because I have xy, I only need to multiply by y squared. Because this has just an x, so that x is right here, right? And then this has y cubed, so I need my y's to equal y cubed. So y times y squared is y cubed. So my answer is, let me erase all these crazy arrows so that you can see it better, is this right here. Okay, 3xy times x minus 9 plus 3y squared. Don't forget to end your parentheses. Okay, lots of kids forget that. Okay, let's go on to example 3, and I want y'all to do this one on your own. We have just 2 more, so I'm going to have y'all do both of them on your own. 14a cubed plus 21a. Okay, so hit pause and go ahead and solve this one on your own. Okay, y'all should be back now. First, we're going to find the greatest common factor for 14 and 21. So for 14, it's 2, 7, 14. And for 21, it's 3, 7, 21. So what's the only common factor they have is 7. So that's the number I'm going to take out of this. You do not have to write this all the time if you can just figure it out in your head. Lots of kids can do that. You just take 14 and 21 and say, what's the highest number I can divide both of those by? Okay, and the answer is 7. Oops, I should not have put my parentheses because I didn't check my variables yet. So I have a cubed here and a here. So the only variable I can take out is an a, right? Because I can't take out a cubed from this one because there's not 3 of those there. There's only 1. So I take out 7a, and now in my parentheses, what's left is 2a squared plus 3. Okay, so that's my answer. And if I want to go back and check, I'm going to go like this. 7a times 2a squared is 14a cubed. And 7a times 3 is 21a. So do those match? Yes. So this is the correct answer because those two match. Okay? So this is why we learned multiplication a while back, is to be able to do things like this, the factoring. Okay, last example, example 4. And you're going to do this one on your own also. XA squared plus XY minus X. So notice this one does not have any numbers in it. So you don't have to factor out any number. You're just looking at the variables. So look for what they have in common. Okay, go ahead and pause and try it on your own. Okay, now that you're back, you should have looked at all these variables and said the only thing they have in common is an X, right? Only one of them has an A and only one of them has a Y. So X is the only thing that I can take out of the parentheses. And that will leave me with A squared plus Y minus 1. Don't think, oh, that's an X, I have an X, so that's 0. That's not how it works. You have to be able to multiply this by something to get that minus X. So X times -1 is -X. Okay, so that's my answer. I'm just going to go in and check it to show you in case you're like, oh, I don't know how she got that. I go X times A squared is XA squared. X times Y is XY. And X times -1 is minus X. And now I look, are these the same? Yes, they're the same. That means it checks. I did it correctly. Okay? And that's it for today. We will be doing a lot of factoring in this chapter. The chapter's name is Factoring Polynomials. So it gets harder from here. You need to be able to do this type of factoring first before you learn the other types of factoring. Okay, that's it for today.